what is the INCREASE project about? The INCREASE project looks into finding new recycling solutions for electronics and electrical equipment in order to increase the share of recyclate in those appliances. And the INCREASE project at the core on the technical side looks into three different recycling technologies, which is mechanical recycling, which is the most common one, and also solvent-based and chemical recycling, which in this case is pyrolysis. And we do this on really hands-on and practical applications, and therefore we have 5 core business cases coming from companies across Europe that use plastics in their products, and they have very specific requirements and challenges that we are tackling. So the plastics we are producing in the project need to fulfill strong requirements, for example, on chemical resistance, on food contact appliances. They have to, in another case, prove to be able to perform electrostatic discharge. We are looking into flame retardants and flammability, and also in medical applications. So you can already see that those requirements come with a lot of challenges. And that's why we are not only looking into the mere technical solutions, but really the INCREASE project is about understanding or developing solutions across the entire value chain. So we are really looking into the entire recycling system from consumer perspective to what is available in terms of waste and waste management. We are looking into, of course, also the environmental and cost side of those solutions, and also on regulation and policy, and do that for those 5 business cases. And today, my colleague Max will tell you something about really understanding the systemic approach and understanding more the underlying systemic conditions and also approaches on how to transition towards a circular recycling economy, let's say. And therefore I hand over.
Joining this webinar. My name is Max Marwede, also working in the INCREASE project, mainly working on the system design topic, coordinating the activities here. And today I will give a short introduction, what is system design, what is a system, and also explain to you what research question we asked or we wanted to get answered with our system design. Then present our current system map, which we iterated 10 times to come up with our current description of the circular plastic system for our products in the project. I will also speak a bit about system transition. So because our current system doesn't fit the needs basically in industry, so supply and demand does not fit in the current system, and therefore the question is, what are the leverage points and interventions you can do to shift the system into a more desired state? The desired state means that the system provides the quality and quantity of plastics fit to the demand of the industry. And if those intervention strategies are in place, you can say we reached a different state in the system, a new kind of system, and we created this, let's say, goal, this vision for a circular plastic system, which I also present. One excuse up front, I'm using Miro as a presentation tool and it's a bit buggy. So excuse if it's not fully smooth, the presentation, but let's see how it works out. So first of all, why system design? Yeah, one reason is the challenges of today's are complex and nonlinear. You know that speaking about climate change or mobility transition or whatever type you think of, healthcare, all those systems are very complex and everyone is working on bits and pieces, but maybe just sees not the full part, not the full elephant, but only pieces of the full system. And we want to create the full thing. And if you just I want to see the full thing to not only react to like symptoms we see, but actually understanding the systematic causes behind those symptoms. And we quite often try linear solutions, although the problems are not linear. And by creating those system maps or however you call it, you create this better understanding of the system and you're able to identify interventions on different levels in the system to change the system. Of course, every system is an abstraction of reality, so it's never the reality itself, but it helps still. So specifically in the INCREASE project, we also used the system design activities we did as a boundary object. So what I mean is here, on the one hand, we created this common understanding in the project, what the fallacies, what the problems in the system are at the moment. On the other hand, we also fed all the information from different partners into one common boundary object, one common system. And every partner could also build on this, right? Because they had the systematic view and they could use bits and pieces out of that result for their own activities. First of all, what is a system model? Usually you have a boundary, so there's basically setting the scope of the system, what you're looking at. You have elements in the system that have relations that basically describe a process happening in the system. You know, that could be a chemical process, macroeconomics, material flow analysis, anything you could describe as a system. And those elements have relationships that could be like mathematical relationships, or as I said, chemical processes, or material flows, energy flows, any kind of relationships between those elements. And usually have input, materials, energy, whatever type of input, and output again, materials, energy, emissions, whatever you can think of into the environment or products or solutions, I don't know what, services, and maybe some entropy losses along the way. Both, not maybe, but most probably some entropy creation along the way. So what we used as our model is so-called causal loop diagrams. In a causal loop diagram, you have elements that are related with each other in a cause-effect relationship. You can have different so-called polarities. And a positive polarity elements move in the same direction, which means if in that example here, birth rate is increasing, population is increasing. If birth rate is decreasing, population is decreasing. There's also negative polarities where in this example here, death rate is increasing, population is decreasing. And if death rate is decreasing, population is increasing. There could be also, of course, delays between those variables or elements in the system. And you can identify feedback loops. What are feedback loops? That are basically drivers in the system which either stabilize or accelerate the system. In a reinforcing loop, it reinforces the development. So in this example here, birth rate is increasing, population is increasing, which again means birth rate is increasing. In the simple example, a balancing loop is drives the system behavior towards a limiting state or limiting condition. In that example here, you have birth rate increasing. That means population is increasing. That might mean pollution is increasing. And with a delay, that could mean that available food is decreasing, which means, again, birth rate is decreasing. So here you have kind of an example of this balancing loop. So how did we, what was our process over the last 2 years, more or less? We started with the stakeholder analysis to identify the barriers along the value chain related to different stakeholders, mainly through literature, but also the survey within the project. And then started to think about how what do we want to get answered with our causal loop diagram. So what is the research question we want to get answered by modeling our system? And the research question we defined is, what are the reasons behind the hen and egg issue, that supply of secondary plastics from WEEE and demand by the electronics industry or by our business cases that do not fit either in quantity nor in quality. And what we want to describe in our system diagram is the availability of recycled plastics, demand and availability of recycled plastics. So we started to map parameters and relationships between the parameters, and both on the supply side and on the demand side. We also categorize those parameters to get a better understanding whether they're technical, economical, ecological, social, or legislative parameters which influence the system. And we iterated this whole process 10 times, as I said, together also with consortium feedback and several sessions. Are now in version 10. It's kind of a never-ending story, but at some point in time, you have to stop doing it. Then, as already said, by analyzing the system and the bottlenecks and blockages and so on, you can try to identify leverage points and interventions. I will explain that later. To move the system to a desired state. And we also developed 4 hypotheses to simplify it a bit and to work on those 4 hypotheses, why supply and demand does not fit at the moment. And together with our advisory board of the INCREACE project, we identified interventions, how to move the system into a desired state, how to tackle those issues. And what we also did, we talked to several of the business cases and identified individual leverage points, so that are specifically related to the business cases, and identified also interventions on that level for each business case, and not for some of the business cases. And then we also needed to define, of course, the desired state. So what is the desired state? So we developed kind of a vision of a circular plastic system. And based on the leverage points and intervention strategies, we set those as underlying conditions so that this vision comes true. And we discussed that vision with the consortium, of course, and refined it. So I already mentioned that the state of the system is basically supply and demand does not fit, or we describe the state of the system of supply and demand in the current recycling or current system. And the main problems in the system, as already mentioned, is the lack of recycled plastic and constant volume and quality, but also the lack demand from the OEMs, but also the end customer, the final customer, the consumer, but also insufficient collection and sorting of plastics. Maybe to mention here, the focus was not so much on the technical developments that were happening in the project or that are happening in the project. So really the recycling technologies, the sorting and so on, but more the non-technical elements of the system. Here, I don't want to go in details, but that was the starting point with all the value chain on the top and the stakeholders in the left, where we collected all the barriers along the value chain and identified barriers, but also already some enablers or possible enablers along the value chain, which could change the system. And with that, that is a jump of from that picture to this picture. It's a jump from like 1.5 years, let's say. So in between, you don't see the steps in between to come up with that system, which looks crowdy, but it's much more simplified as the versions we had before. I tried to go into detail now. So you see the 4 quadrants, which present on the right-hand side the supply side, on the left-hand side the demand side, right-hand side design and manufacturing and consumer acceptance of recycled plastics. That's also, of course, things we're working on in the INCREACE project. And on the left side, consumer divestment. So how can you incentivize people to bring the products back? And of course, sorting and material recycling, not so much the technical issues, but more the overarching issues influencing the whole recycling system. If we go now more in detail, if you look into the OEM side, the brand side, of course, brands have strict quality requirements on plastics. They want to produce good products, and they also have risks related to liability, for example, or aesthetic risk, performance risks. So they want to minimize those risks, of course. But due to variances in colors and other properties, those recycled plastics do not fit the strict quality requirements. On top, at the moment, or usually, it's that virgin plastics are cheaper than recycled plastics. So you have a material with lower performance and higher costs. That, of course, decreases the willingness to pay for recycled plastics. And also data is missing on the quality of the recycled plastics. This is combined with like not really high demand from the end customer side, because also the end customer might perceive recycled plastics as lower quality and are not willing to pay a higher price for products with recycled plastics. The higher price for products with recycled plastic is not only the higher price for the recycled plastics, but it's also the upfront costs of changing the process to use recycled plastic. So all the R&D needed and the product development needed to use recycled plastics. So you have higher upfront costs on the OEM side, which increases the price for the final product. So basically, you have an end customer not really willing to buy a product with recycled plastics and not willing to pay more, which again decreases the willingness to introduce recycled plastics in their products from the OEM side. If you go to the take back, basically collection system, here also whether consumers bring back the end of use products to official collection channels depend on many factors. For example, on the perceived compensation value, it's not really high. I mean, you don't get anything back when you bring your products to the collection point, right? And even the social benefit, if you bring it back, it's not that high. If you think of how optimized the purchase experience is, it's very much optimized so that people buy products, of course. But the experience of bringing products back, like the ease of bringing products back is not as optimized, servitized as the purchase phase. Which means it's quite complicated. You have to maybe take a car to go to local collection points to bring the products back. You don't maybe trust in the system that your product is really recycled well. You don't have the know-how, how to do it, where to bring it. It's hard to get the information, and the compensation value is low. So that means, again, of course, if people don't bring their products back, you have lower volumes of recycled plastics. On the other hand, you have a very high variety of products with a very high variety of plastics in those products. So if you think of double shot, triple shots products, I don't know how many types of plastics are in a vacuum cleaner, for example. For probably, I don't know, 5 to 10 different types of plastics with different types of fillers and so on. So you have a really mixed type of waste, which again makes challenging very processing. So recycling very challenging. Sorry, recycling very challenging, which drives recycling costs up. And that again leads to more export of waste, maybe to third-party countries where recycling costs are lower. And that again decreases the volume of recycled material available. On the other hand, specifically for WEEE, the metal prices or the metal value in the products drives recycling. So recyclers are interested to get the metals back, not so much the plastics. They have a low value compared to the metals, and so the effort they put into that is of course also lower than getting the metals back, which again decreases the quality and the amount of recycled plastics available for the industry. Apart from that, currently the regulatory drivers drive the recycling of packaging waste, mainly, also plastics from packaging waste, not so much from WEEE. There's no, regulation how much plastics you have to get back from WEEE, but there's regulations on how to recycle packaging and how much you have to get back. And this again, the downside of this is that it's usually a downcycling. So the quality of that material is also not fitting the quality or the quality requirements of the electronics industry, and it goes to building and construction. And that again limits the availability of the materials for the electronics industry. Having said this, the question is, how can we change the system? How can we move the system toward the desired state? So Here you see one theory of change, the so-called two-loop model. So every like theory behind this, like every living system has this, the phases of rising, a peak and a decline phase. If you think of yourself as a human being, like you rise maybe in the 30s, 40s, you have a peak in your life and then you decline again. So it's in many living systems, it's the same structure, and you can basically transform this or translate this also to other systems. So energy systems, mobility systems, healthcare systems, whole civilizations. You can also see similar patterns, right? And what's happening is that after a while, after this peak, the dominant system disintegrates, and there's some innovators, some players which already start to innovate around a new system. And what you have to do, and also by disintegrating the old system, new resources become free, right? There's new resources becoming free, but you also have to hospice, I don't know, maybe a good example of Germany is the car industry. We built car industry on combustion engines. Now electronic engines are the um, driving engines. So what do you do with all the people working on combustion engine, all the supply chain? You have to change in the system, and you have to think of what to do with the old system. How do you help the transformation process and transition into the new system and nourish it so that it becomes the dominant system. So that's the theory. And how you do that, you try to identify intervention strategies to move the old system into a new system. What are intervention strategies? That are planned actions or interventions designed to bring about change in the system. And you do those interventions and at so-called leverage points. And leverage points are specific places within a system where small change can lead to a significant shift in behavior or outcomes. So the idea is to have this kind of acupuncture strategy, that you try to find the right point in the system and pick a needle in there, and so that the whole system moves. And there's this model of the iceberg. You have what you see are the events. So basically, what you see and hear are the events, and you usually quickly fix the problem through some direct linear action. So that kind of the symptoms you see, right? So think of heavy rainfall. So you see heavy rainfalls. Okay, that's the symptom. So you might adapt the city planning to heavy rainfalls. What you also see are patterns. So that's basically changes in variables that occur over a period of time. So you see that heavy rainfalls, instead of having them 3 times a year, you have them 5 times a year. Okay, that's something you can adapt on, you can maybe plan for, right? But below that is structures. So structures that basically the rules of the game. So information flows, hierarchies, maybe rules, and so on. So if you see the patterns, you don't still see kind of the development of symptoms, but not the structures behind. So still staying in the same picture with the heavy rains, maybe the structures is that we emit CO2, and CO2 rises, rises temperatures and so on and so forth, the whole story. So we build an energy system built on fossil fuels, and the energy system is the structure we're working with. And below that are the models. So that's the highest leverage you can have. So the models are basically the paradigms, the the goals in the system, the mindsets, and so on. And here maybe the paradigm is extractivism. You know, we have fossil fuels, they're there, we can extract them, they're nearly for free. And we couldn't do that as long as we want. So that's maybe the paradigm behind using fossil fuels for energy creation and so on and so forth. So there you see kind of the different levels in that iceberg model. And the list of leverage points were created by Donella Meadows. She was co-author of the, I would say, pretty famous book, Limits of Growth, and a very famous system modeler. So what is our logic here, or what's the general logic is, you have the current state, like the current system with its flaws and shortcomings. You see on the event and pattern side, and you want a desired state in a kind of ideal version. And the theory behind this, you identified leverage points, so potential for intervention, of course. High leverage is better than low leverage. Then you do the interventions, the actions to change the system at the leverage point with a solution, a concrete solution which might be feasible and plausible to implement. How did we identify those leverage points or intervention strategies? I mean, we do a lot already in the project, of course. But we also wanted to identify intervention strategies, leverage points, which go beyond the scope of the project. And we also asked our advisory board for help by having a workshop with them, and we created this 4 hypotheses based on the analysis of our system map. And as already mentioned, maybe a bit repetitive, is that we know that, or we suppose that consumers may exhibit low acceptance of products containing recycled plastics due to concern over the perceived quality and safety, and also the lacking awareness. And brand owners may resist utilizing recycled plastics because of higher upfront costs associated with redesigning products and validating compliance with quality and safety standards. And this is, of course, combined with the lack on the consumer side, lack of demand on the consumer side. In the recycling system, there's a lack of economic incentives and regulatory frameworks to focus on the recycling of plastics, so the focus on recycling of metals. And those lack of return of investments lead to insufficient investments in new technologies and infrastructure. But again, leads to a low quality supply of recycled plastics, which is not suitable for the electronics industry. And on the collection side, so again, consumer side, collecting the product, you have maybe a population of people who are not aware of the plastic recycling system, how it works. There's no incentives to bring, or the incentives are really low to bring the products back. So that's also an issue. And based on this, not only based on this, but also based on this, the whole consortium identified, I don't know how many are those, maybe 50 or more intervention strategies on the different levels. I don't want to go in detail here. I just want to show you how much of type of interventions we have, how many interventions we have, and of course, of some of those we are working in the INCREACE project. On others, we're not working in the INCREACE project. And now I already want to show you the vision we created of of the future recycling economy or sustainable circular plastic system, which means this system increase the availability of recycled materials, simultaneously reduce the use of virgin plastics, and stays within planetary boundaries while achieving social goals. There's some conditions below. For example, it's economically viable to substitute virgin plastic with recycled plastics due to policy incentives. The overarching goals of the system is to enhance the circularity of the products, providing high quality post-consumer plastics by optimizing collection and recycling, increasing the recycling content in the products, decreasing dependency for foreign raw materials, and minimizing environmental and health impacts of the industry. There's what we see here. We again worked with the iceberg model to define or to identify, based on the leverage points, intervention strategies, the underlying conditions, so that this vision comes true. We have now 3 colors, color coding. The green boxes or the green post-its are things INCREACE is working on. The orange boxes are things INCREACE is working on a theoretical level. And the red boxes is leverage points we identified, but INCREACE is currently not working on changing those. So if you go into detail, hope you can read it. So here on the event levels, it's you should reduce the export of waste to non-European countries, for example, so export bans, of course. And it's important to trace the type, composition, and amount of polymers cradle to cradle. In general, consumers should should have the habit to return the product after use. That means consumers are aware and trust in the collection channels and in the recycling system. Collection is convenient and brings value, like social value or monetary value or whatever. And of consumers' trust, of course, in the recycled materials, and acceptance of recycled plastic is high. And design measures are in place to increase the acceptance of recycled plastic. There's a trusted system, so quality is verified along the value chain. Trust is built through data and stronger collaboration between recyclers and OEMs. And quality data is available along the value chain. One other thing INCREACE is working at is to fit the source, different plastic sources, so type of products, with the required demands. So required quality on the demand side, on the OEM side. And that would mean you restructure the system so that the quality of waste and the product requirements decide on the recycling pathway. And the waste streams are optimized according so that you get the best outputs for the quality requirements, or the best output that fits the quality requirements. Other like intervention strategies where we don't work on are, like, for example, limiting the number of plastic types and additives allowed to be used. That, of course, also hinders recycling or makes recycling more complex. If you think of flame retardants that were allowed maybe 10 years ago, and now they're not allowed anymore, so you cannot really recycle the products. And other examples are that you set recycling fees, or you modulate recycling fees according to the recyclability of the product. What we work on again is that companies have the capabilities and the know-how to work with recycled plastic. So that's really part of INCREASE project, of course. By, for example, providing or recreating in the project designed from and for recycling guidelines. What is important is that, of course, supply and demand policies are in place. So we work on like we suggesting what type of policies that could be that make less sustainable materials more expensive than virgin ones. If you go on a higher leverage, really on a paradigm level, narratives should be changed from new is better, we can use as many resources as we want, fossil resource or whatever type resource as we want, and abundance towards sufficiency, planetary bounties, and well-being. And there should be supranational agreements on those planetary boundaries, and states and companies should act within those boundaries. And of course, at the end, any economic system, not only the plastic system, should serve the well-being of society, as the main goal. With that, I would already end. Thanks for listening, and you can ask any questions.
Thank you, Max. Are there questions from the audience? I think it was quite a lot, but maybe there are some. Will anyone